All right, last section, here we go. So for this first one, we are going to let Pxy be a point on the graph of y equals x squared minus 1. And our first task is to express the distance d from point P to the origin. So the distance from P to the origin. And what this sort of looks like, we have x squared minus 1, so down 1, x squared. And then point P is somewhere like over here, xy point. And there's our origin. So this is what about it looks like. So if we were doing the distance formula between a point and the origin, we would do d equals, and so one of our points is 0, 0, and one is xy. So that's where we're going to plug into our distance formula. So the square root of x minus 0 squared plus y minus 0 squared, which equals the square root of x squared plus y squared. We are going to substitute from our equation y equals x squared minus 1 into this equation. So the square root of x squared plus x squared minus 1 squared. Once you multiply x squared minus 1 times x squared minus 1, we get the square root of x squared plus x to the 4th minus 2x squared plus 1. Simplify that, you get the square root of x to the 4th minus x squared plus 1. And so that's what our distance would be. Then we're going to do what is d if x equals 0. So we're just plugging 0 into that equation we just found. So the square root of 0 to the 4th minus 0 to the 2nd plus 1, which equals the square root of 1, which is 1. Now we're going to try when x equals 1. So the square root of 1 to the 4th minus 1 squared, and then plus 1. 1 to the 4th is 1, 1 squared is 1, so 1 minus 1 is 0, and then 0 plus 1 is 1, which equals 1. What is d if x equals the square root of 2 over 2? So we're going to plug in root 2 over 2 for x. So the square root of root 2 over 2 to the 4th minus root 2 over 2 squared plus 1. Root 2 over 2 to the 4th is 4 over 16 minus root 2 over 2 squared is 2 over 4 plus 1. Plug this in our calculator and we could get the square root of 3 over 4, which you can separate to root 3 over root 4, which equals the square root of 3 over 2. Next, using the graphing utility, graph d and find the values of x at which d has a local minimum. So I'm going to go ahead and graph the function. Symbol. So the square root of x to the 4th minus x squared plus 1. And we want when x is greater than 0, so we're really only looking at this part of the graph. I'm going to touch near that minimum value, menu, function, extremum, and find that that minimum occurs at x equals 0.71. Then we are going to go to the next example, and this is the last problem. So a rectangle has one corner in quadrant 1 on the graph y equals 25 minus x squared, another at the origin, a third on the positive y-axis, and the fourth on a positive y-axis. So I'm going to draw what this looks like, and then we're going to start with A, express the area A as a function of x. And if some of you did the honors extensions in Algebra 2, you might recognize this problem. So I'm going to just draw what it looks like kind of above. So we have this graph, and here's the rectangle in the first quadrant, and then the x squared around it looks like this, touching like each of those. Let's see. Oops. Whole. Make this taller. Kind of like more like that. Okay, that works. So we have this point. Let's label them 0, 0. This way we go in the x direction, 0 in the y. This one's x comma y. And this one's 0 in the x but y. Alright, so express area A as a function of x. And as we know, area of a rectangle is length times width. And the length of this, which is this blue piece, would be x minus 0. So this value minus that value. So x minus 0. So the length equals x minus 0, which just equals x. And our width is y minus 0, which equals y. So that we can put this back in, that it equals x times y is our area. And then our y, we also were given in our original equation that y is 25 minus x squared. So for this, what we're going to plug back in is a equals the length, which is x, times y, but we know y equals 25 minus x squared. And then if you want to simplify this, let me shrink. Oh. Why does it do that? Stay. Okay. If you want to distribute the x into the parentheses, we get 25x minus x cubed. So that is the expression, the function for the area of this function. So what is the domain of A? Since xy is in quadrant 1, that means x has to be greater than 0 and y also has to be greater than 0. So we're only looking at that first quadrant. And then since we then also have to have our one equation that was given greater than 0. And so I'm going to solve. I'm going to add x squared to both sides. And then square root both sides. So I have x is less than 5. And when you take the square root, you get plus and minus, but as we know, x has to be greater than 0. So that's why we're just keeping the positive 5. So our domain, x such that 0 is less than x, which is less than 5. And then we're going to graph this, graph that equation that we got, the 25x minus x cubed. And it goes through here, here, and it has about 50. You can plug this in your graphing calculator and get what the graph looks like. And then for what value of x is the largest area? So here we have a parabola. So what we're going to do is do our second trace and then find our max. So let's go plug that equation in our calculator. So 25x minus x cubed. Press OK. Plot. Here's that first. I'm going to scroll up to where that is. Press menu, function extrema. And our x value is about 2.89. So x equals 2.89. And so that is our x value that gives us the largest area. All right, let me know if you have any questions.